Welcome to everyone to today's Friday Talks of the NH. Today, in our workshop number 18, we have the pleasure to have with us the group of the National University of Colombia with prospectivity of the Cenozoic units from the upper Magdalena Valley. So, in our schedule of different talks, today we are in prospectivity, as I said before, prospectivity of the Cenozoic units from the upper Magdalena Valley. Next week, on June 24th, we have the number 19, that is the seismic interpretation in area research by the ANH. We have Nueva Granada, that is a seismic survey acquired by the ANH in 2018. As well, we have the lower Magdalena Pailitas, well drilled by the ANH last year. And as well, for all of the students that are interested, we'll have details for financial help to postgraduate and last year students by MinCiencias. So please be aware of this talk for more information. So in the different talks that we have presented during this year, we have presented 28 areas, different areas for being nominated by any company that's interested into being explored in this country. We have a gas and condensate, light oil, medium oil, and heavy oil. And in the link that will be shared later on into the chat of this talk, we'll be sharing the link that you can find any of the previous talks that have been presented during the year. So today's speakers, we have Javier Guerrero. Javier Guerrero is a geologist from National University of Colombia. He obtained a master and PhD from Duke University in the areas of stratigraphy, sedimentology, and paleomagnetism. He participated with multidisciplinary group of geologists and paleontologists from several American universities into a project by stratigraphy, sedimentology, and magnetostratigraphy of the Onda Group and the Tatacoa Desert, in the Tatacoa Desert. Javier worked at the stratigraphy section of Geominas, today the Colombian Geological Survey, in various projects of the Cenozoic from the Magdalena River Valley. During several years, he has been a professor of the Department of Geoscience from the National University of Colombia, lecturing courses in sedimentology, sequence stratigraphy, and regional geology. Javier has carried out research in consulting projects for several petroleum companies and from the National Agency of Hydrocarbons, ANH, on rocks of the Cretaceous Colombian Bacar Basin and the Cenozoic Foreland Basin. We have as well Maria Emily de Roca. Maria Emily de Roca is a geologist with a master's degree in the formation of the lithosphere, Basin analysis, and petroleum geology from the University of Marie Curie in Paris, France. She has 10 years of experience in the hydrocarbon industry and academia. Maria started as a logger in the Schlumberger company in the first shale gas wells in the Vaca Muerta formation of the Neuquén Basin in Argentina. She is now working for neo-oil exploration as a seismic interpreter. Additionally, since 2016, she has been linked to the Universidad de los Andes as professor of the course on structural geology and tectonics. We had as well Shahid Kairous, Edgar Shahid Kairous, that most of you know well. Shahid is an exploration geologist from the National University with a specialization in hydrocarbon management from the Santander Industrial University, WIS. He led many exploration projects at Ecopetrol, and he was also TUG EAMP exploration manager. He is co-founder and general manager at Neo-Oil Exploration, focused on petroleum systems, seeking new plays, new blocks, and prospects for exploration. We have as well Álvaro Vargas. Álvaro Vargas is a geologist with masters in geology from National University of Colombia. He has more than 20 years of experience in applied structural geology, with emphasis on design, collection, analysis, interpretation, and QC of information from potential fields and magnetotelluric methods. Álvaro was an interpretation advisor and technical manager of Carson Helicopters Inc. Aerogravity Division. Since 2006, he is a founding partner of Lithosphere Earth Science, where he has developed more than 55 successful exploration projects for the oil industry in the United States, Canada, Colombia, Belize, Mexico, Guatemala, Ecuador, Peru, Brazil, and Argentina. He is the author, together with Victor Glaterol, of the Potential Field Maps of Colombia, published in 2010 by the ANH. And last but not least, we have Cesar Moore. He's a geologist with a master's in petroleum science and 34 years of experience in petroleum exploration projects. Expertise in petroleum geochemistry, petroleum system modeling, and yet to find assessment. director, coordinator, and interpreter in projects in companies such as Ecopetrol and Cipetrol. Since 2004, Cesar has worked as a consultant, and since 2014 as manager of Cuenca Asesorías Geológicas SAS. He has also been a professor of petroleum geochemistry and petroleum system modeling at several Colombian universities. Next week, remember, we have in our workshop number 19, Seismic Interpretation and Reserve Areas, Nueva Granada Seismic Survey, the Lower Magdalena Stratigraphic Well Pailitas, and the details for financial help for postgraduate and last year students from Ciencias. So I'd like to give the stage to the Universidad Nacional. Thank you.
Good morning, everybody. We're going to present a talk on the prospectivity of the Cenozoic units from the upper Magdalena Valley. First, I am going to talk about this regional geology, stratigraphy, and sedimentology. Maria is going to present the seismic interpretation. Alvaro is going to present the fieldwork. Shahid is going to present petrophysics. And Cesar is going to talk about petroleum systems and yet to find. So let me share my screen, please. Okay, so this is the stratigraphy of the area of the upper Magdalena Valley. It begins with the Aptian strata. This is the stratigraphy published, several papers, as also is the stratigraphy used by the Colombian Geological Survey. The succession is made by transgressive and regressive sequences, intervals, which are mostly marine in the Cretaceous and mostly fluvial in the Cenozoic, with some marine intervals. There is a major unconformity, which is very important for prospectivity. Just before the Honda group deposition, at about 16 to 14 million years ago, this whole sequence was uplifted and eroded up to 4 kilometers in the vertical. And it eliminated in some places the whole sequence and exposed the basement. And in other areas, yes, eroded most of the Cenozoic and placed in contact the Honda group with all these Cretaceous units, which are many of them are salt rocks. So this is the main concept. These East Virgin Faults are the result of the east movement of the Central Cordillera during the Middle Miocene. So all these units, as I was saying, were uplifted. Some parts of the Cenozoic units were preserved in synclines, but in most areas they were just eroded. So it places the salt rocks of the Cretaceous in contact with the sandstones of the Honda group, which is the main important concept. And they are capped by mudstones of the Villavieja formation of the Honda group. This is the East Virgin Faults, the Andalusia Fault, which are the Middle Miocene. And these faults, which are West Virgin, are the result of the uplift of the Eastern Cordillera, and they are of late Miocene and mainly Pliocene age. So we have both styles with different timing in the area. And in this case, the whole sequence was eroded. So the Honda group rests on the Jurassic basement. And in most places, it will be something like this, the Honda group resting on top of the Cretaceous. This is the synclinal Wallandai incline, and most of the sequence was preserved, but over here we don't have the Honda group. We have again the East Virgin Faults, and also in this place of the valley, the West Virgin Faults have moved to the west and placed in contact some of these units with the Cretaceous. So there is some oil seeps in some of these rocks. but mainly the vertical migration of hydrocarbons from the Cretaceous to the Cenos to the Paleogene is not favorable. This is the main concept of the fluvial deposition for the Cenozoic Colombia. So it will be meandering rivers for the Honda group and the fine-grained units within the Wallandite and other units. And the coarse-grained units will be more like these braided stream rivers, strike rivers, conglomerates, and sandstones. So as you can see, these belts will be separated from each other from mudstones, and they will continuously move against each other. So we have sandstones connecting to each other. The drainage of the Honda was directed to the east and southeast most of the time. On the uppermost part of the unit, the Eastern Cordillera began uplifting and the drainage just changed. It was just very few meters of the top of the Honda group before another unconformity and before the position of the Neiva and Gigante formations. Sandstone thickness in belts in sandstones, it is possible to measure the sandstone is the depth of the river. So in the La Victoria formation, we have more energy, more sandstones, and they are up to 10 meters thick. So channels up to 10 meters depth, and they will combine to make multi-story bodies up to 26 meters wide, which will be the reservoirs. And oil has been found in the lower part of La Victoria formation and even in the sandstones of the Villarreal formation in several fields. The thickness of the measuring the field, the thickness of sandstones, as I was saying, will be related to the width of the channel, the width of the meander, and this is a measure in the field of the width of the sandstones, which could be up to 4 kilometers. So it would be something like a sandstone 25 meters thick that could be 2, 3, or 4 kilometers wide, and those will be the reservoirs. This is the geochronology of the Honda group, which is very well established. This is magnetostratigraphy that we made a few years ago. Our dates, which we calibrated it. This is a paper by Montes that took it. They also provided a new age, also Horton and others, Anderson and others have provided some zircon, the reactive zircon. So it is very well established between 13.6 and 12 million years. And there is another unconformity in here, and the neighbor formation is boundless again, which is the equivalent of the Guayabo formation on the other side of the basin. This is how it looks in the field. This is a floodplain mudstone. These are roots. This will be mostly paleosoils. And these sandstones, in this case, 3 meters thick, typically fining outwards, which is the mark of the Meandrian rivers. This is near Tocaima. This sandstone has 7 meters thick, and there's a mudstone below, a mudstone above, but these are the sandstones in which we would be interested. As I was saying, they could be mostly multi-story bodies up to 25 meters, or maybe in some places. This is the other unit, it's the Paleogene unit, in this case, the Thessalian formation of the Wallandite group in the type locality. Those will be mostly conglomerates, pebble and conglomerates. And they have some oil asphalt seeps. But as I was saying, it's just because in that area, the Cretaceous has been uplifted against this, but it's a very strange situation. This is not the depth reservoir, as we will see later. So the main concept here is how the central cordillera here migrated towards the east and then uplifted in the middle Miocene and uplifted all these units up here in the valley. And after that, the central cordillera retreats again towards the west. So the area which was uplifted in the middle Miocene collapses again, subsides again, and the Honda groups is deposited on top of all these Cretaceous units, providing a path of migration between these hydrocarbons and the sandstones of the lower part of the Honda group. So thank you, and next will be Alvaro. Thank you. Álvaro.
Okay, thank you. I will share my screen. Okay, good morning, everybody. Now I am going to talk briefly about the field work carried out to better understand the Wallendian onda groups in the Sinusoid era. We were able to survey 5,372 linear meters of stratigraphic columns, of which we recorded 4,480 meters with a complete radiometric signature. My colleagues on the field are named on this slide. I am very grateful and proud of all of them. We work hard in sometimes difficult conditions amid pandemic restrictions. On the geological map at this scale, only the relationships between the different geological periods in the upper Magdalena Valley can be observed. On the geographic map of the right, we can see the location worked in the field. Green colors will correspond to the Cretaceous, yellow color correspond to the Cenozoic, blues and purples to all the rocks. It's important to say now on that the strata of the Honda group correspond to river environments with the meandering bottoms, conglomerates lateral adjacent to the west correspond to braided rivers in alluvial fans. We collect 200 samples in the field, and after a rigorous selection, we selected 148 for different laboratory analyses. Here we can see the large amount of radiometry data collected. Apart from the usual total count, the different isotopes of uranium, thorium, and potassium were recorded. This is very useful for correlation purposes. Here in red lines, the location of the different sections worked in Palermo Villa, those of the north on the right and those of the south on the left, all within the Wallandai group. That includes the Palermo, Bache, Tesalia, Potrerillo, and Doima formation. Survey statistics can be viewed on the slide text. Maps hinting at the geology shows the location of the sections. This is what the outcrops look like in the northern sector of Palermo. Here are the structural sections of this sector. We work along the southern bank of the Bache River. On the map inside the circle, the location of the geology of the region. The basal section is called Bache. In the middle, Farfan, and the youngest section, it was called Boquerón. This last section has almost complete outcrops of the entire Wallandai group, including the Palermo basal Bache formation on the first stratigraphic column, middle Bache in the second, and the complete formation sequence on the Boquerón sector with 1,042 meters measured in the field work. On the southern sector, we find a small 42-meter section here, which we call Teruel. Further to the east in the Moyas Ospina sector, like this, we find a small window of the Potrerillo formation on the base, and 462 meters of the Doima formation. At the end, after a cover stretch of 50 meters, the Saldaña formation could be seen. In the Chicoral section, the department of Tolima, along the road that leads to Ibagué, outcrops of the Bache and Tesalia formation can be found. There we work 269 meters with radiometry. Here we can appreciate the stratigraphic relationship between the two formations mentioned. The contact is here. To the east of the town of Chaparral in Tolima, we work 3 sections that involve the Tesalia, Potrerillo, and Doima formation on the core of the syncline here. There is the lower part of the Honda group represented by the La Victoria formation. Here is the graphic representation of the surveyed section with the radiometry spectrum and their location on a geological map of the sector. The section that we work along the ICO stream allowed us to see a good section of the Potrerillo formation, the Doima formation, and the La Victoria formation. On the left, you can see the complete column with all its descriptors. Magnificent outcrops of the Doima formation can be found along the road that leads from Carmen de Apicalá to the east. There were we are able to work 256 meters of this formation. Here, some aerial views from a drone that allowed us to appreciate the stratigraphic continuity of this section. On the left, the representation of these outcrops and their radiometry signature. In the desert of La Tatacua, we find 1,467 meters of mainly fine sandstones and mudstones from the continental environments of meandering rivers. On the right, you can see what the desert looks like in Google Earth. There, the trace of the raised stratigraphic section have been located. Here I have put some aerial views toward the south from a drone to appreciate the gentle inclination of the strata found in the desert. They never exceed 10 degrees. Cerro Gordo and Cerro Chacarón are prominent exposures of the Saldaña formation. The best exhibition of the Honda group are definitely found in the desert of La Tatacua. They are also the best studied and best documented. There is a paleontological museum inside the town of La Victoria, located to the west of the Cerro Chacarón section. On this slide that I have to show you, the last I have to show you, you can see the stratigraphic columns raised in the field and the radiometric signature. That's all. Thank you for your kind attention.
Good morning. Thanks for your time. Now I am going to show something about the petrophysics. First, I want to show you the correlation that we did with the data from the field and the data from the wells that have been drilled in the basin. Here on the left, we have the stratigraphic column of Palermo sector. This is the Palermo unit. In the Chicoral group, we can see the massive sandstone. And here in the middle is the part of the Palermo unit in the well Gigante 1. We can see the massive conglomerate and how it correlates very good with the outcrop data. And here in the right side, we have the sonic porosity against gamma ray. And we can see that for this unit, we had a porosity between 6 and 9%. Next, this is the same well, but This is another outcrop. This is the Grupo Gualanday in the Palermo-Teruel area. We can see the massive conglomerates at the base of the unit and how it correlates very well with the Gigante 1 well. This is in the Neiva subbasin. Next, this is the Bache formation. This is the data from the outcrop, conglomerates, sandstones with some intercalation of shales. Here is in the middle part is the log of the Babilla 1 well. We can see the same pattern of lithology, sandstones, conglomerates, and shales. And here we have the neutron and density porosity, and the values are between 6 and 12%. And now this is the Potrerillo formation. This is mainly shales with small amounts of sandstone. Here is the log in the Babilla 1 well in the Neiva formation. And we have a low value of porosity here too, between 6 and 12%. This is a sonic porosity. Now I am going to show the La Victoria formation. This is the outcrop data. Sandstones, shales. This is the Babilla 1 well in Neiva subbasin. Some of the sandstones that they show good porosities and maybe good opportunity for oil accumulation were tested. Here is the data. The data of the porosity from density and neutron is between 18 and 27%. Here in the La Victoria formation of the Onda group, we had a better development of porosity. And this is the Nunda 1 well, the same unit, La Victoria formation, the data from the field, the data from the log in the Nunda 1 well. This was a well that tested oil not commercial at the base of the unit. Here we have values of porosity between 9 and 21%. Here is a detail of the base of the Nunda 1 well where the oil was tested in this unit. We had a porosity between 12 and 24%, but we had a shale volume between 0 to 20%. Maybe this amount of shale in this unit can affect the permeability of the unit, and maybe this is one of the reasons that we don't have a commercial production in this well. With the samples we took in the field, we took samples and we made a laboratory analysis of permeability and porosity. This is for all the samples that we took from the Gualanday and Onda formation. We had a lot of values with very low values of porosity and permeability, and here at the top we have some samples with permeability higher than 100 and porosity between 15, 22, 23%. This is for all the samples that were collected on the field work. Now, this is only the data from the Neiva and Girardot subbasin for Gualanday group. We see that for this Gualanday group, we had lower values of porosity and lower values of permeability. Permeability in most of the samples are less than 1 millidarcy. There are 2 samples that they had better values of permeability between 40 and 100 millidarcy. Porosity is close to 25%. Now, this is the data from the Onda group for sample from the Neiva and Girardot subbasin. Here we have, or we can observe that we have better values of porosity and better values of permeability. There are several samples that they have 100 or more millidarcies of permeability, but there is another group of data with low values of porosity, less than 10%, with a low values of permeability, less than 1 millidarcy. Now, we want to compare what happened with the data from the fields that there is in the basin. Here is data from Palo Grande 1 field. This is from sample from cores or sidewall cores. We can see that for this unit and in this well, we have in this field, excuse me, we have porosities between 20, 30% and values of permeability between 10 and 100 millidarcy. There are several samples that they have close to 500 millidarcies. And another field that we have production from the La Victoria formation is in the Andalusia field. We have data from 20, 25, 26% of porosity and higher values of permeability. There are a lot of values between 100 and 1000 millidarcies. We can see that there is a better development of porosity and permeability in the La Victoria formation. Excuse me. Now, this is the Olini-2 well in the Girardot Basin. This is for La Victoria formation. We can see the logs, the development of the sandstones and the values of porosity between 15 and 20, 21%. This is from neutron and density logs in order to define or determine the porosity. And now this is the Rio Saldaña 2 well in the Girardot Basin. We had a good development at the base of La Victoria formation of sandstones. We had porosity between 15, 21, 24%. These are from neutron and density logs. And now at the end, this is the Samarcanda 1 well in the Girardot Basin. At the base of the La Victoria formation, there are several sandstones that they have shown some production of oil. Here we have a porosity between 12 and 19% and volume of shale between 20 and 40%. And now we return to the Nunda 1 well at the base of the La Victoria formation. I mentioned that it was a non-commercial production well, and the data of the porosity is between 12 and 24%, and the volume of shale is between 0 and 20%. This amount of shale maybe should affect the permeability. Okay, thank you.
So good morning to everyone. I will present you the result of the play definition in the Honda group from Seismic Interpretation. Just 1 minute. Okay. Okay, to start, we have elaborated 27 seismic sections in all the upper Magdalena Valley Basin in order to improve structural and identify area of interest for the Honda group. So in the right, we have seismic section for the Girardot Basin at the north of the upper Magdalena basins. And on the left, we have the neighbor sub-basins with its representative section lines. What we can see is that the upper Magdalena basin is limited by 2 fronts of deformations with opposite vertices. So indeed, in the eastern side, we have the Suarez, Pedal, Algeciras, and Garzon river system fault with a divergence to the northwest. And we can see it here in these seismic lines. And on the other side, at the western edge, we have the Chusma, San Francisco, and Pacandi fault, reverse system fault with divergence to the southeast. So the Neiva subbasin is also divided lengthwise by the San Jacinto Betania fault, as we can see in this X-mark line, which exhume Cretaceous rocks and some older rocks on the Neiva syncline, which is a very important feature because of the thickness and because all the sequence, the sedimentary sequences are preserved from the basement to the Willa group from Pliocene. In the northeast of the Neiva subbasins, we also identified imbricate system thrusts. And we can see in this section line, in the seismic sections, that the Honda group are lying unconformably, in angular unconformity, on the Cretaceous rock. And it's affected by some thrust propagation faults related to the reactivation of some thrust of the imbricate system thrust. So for here, Neiva subbasin, the area of interest is this yellow one, where we have the Honda group presence. And for Hidrocarburos subbasins, as we can see in these sections, we can see that we have the Honda group present in the central area. And to the south, we can see that, we can see that this central area is fragmented into 3 smaller basins. So this yellow area was the first interest zones. However, we wanted to define a bit more these sectors. So what we did, and we made a database with the well, which report hydrocarbon shows only on the Honda group. And with it, we improved the first area, the yellow one, and we propose a blue area, like the new sector of interest. So here we have a list. In Hidrocarburos, we have these wells with hydrocarbon shows in the Honda group, like Cabalonga, Calarma, Chenche, Chicoral, Canelo, Geopozo, Poseidon, Ventarón, Aleli-1, and Olini 2. And for the Neiva subbasins, we can see that most of the wells are in the northeast sector of the Neiva subbasins. We have Casica, Corinto 1, Gaitana 1, Guanabana 1, Nonda Southwest, Nonda 1, Palo Grande 1, Polonia 1, Yarumo 1, and Dinati 165. We have also, outside of these blue polygons, Gigantes and Tarqui wells that we didn't include in our study. So the aim of this work was to identify the main existing plays associated to the Cenozoic Honda group. And we have been able to identify 5 plays, 3 structural and 2 stratigraphic that I will present you in the next slides. So we can see in the chart the petroleum system associated to the Honda group. The source rock are composed by the marl and claystone of Caballo, Tetuan, and Loma Gorda formations. As reservoir and seals are related to the Honda group itself because of its fluvial deposits. And the age of the trap is related to the kind of plays. When the play is stratigraphic, we have the same age of the group, the Honda group, middle Miocene to Upper Miocene. And when the play is structural, the age of trap is related to the age of deformation. Reservoir, as we can see here in the stratigraphic interpretation, are made by sandstone related by channel deposits. There are some sandstone with very good petrophysical characteristics. As we can see here, we have a porosity in the very good range between 20 to 25%. And for seals, we have two kinds of seals: the local seals, when we just have been able to define it in one well, or regional ones when we have been able to identify it in several wells. So first place is a stratigraphic play. It's related to channels and valley field deposits. It's associated to the sandstone at the base of the Victoria Formation, as we see previously. And this sandstone field paleotopography of the basement, in this case, the basement is composed by Saldaña Formation. It's a Provence stratigraphic place. Andalusia Sur, Rio Ceibas fields are example of it. And we also have non-commercial discoveries in the Nonda 1, in Nonda Southwest, and Casica 1 wells. For the location of this play, we propose two areas, the pink one here in this map. For the Neiba Subbasin, we can see in this section line that the area is between the Andalusia fault and the Palo Grande fault. Here we can see how the Victoria Formation field paleotopography as a basement, and at the same time we can see it in the Girardot Subbasin in the central area between the Prado fault and the San Antonio fault at the north of the Natagaima and Pata Paleo heights. We can see here how La Victoria Formation filled some valley of incisions. For the same place, we also work with seismic attributes. So from 3D seismic, with the 3D seismic volume called Neiba 3D near the wells Polonia, Casica, Nonda, and Timanco. We ran some seismic attributes. So first, we interpreted the top of some sandstone in wells. We identified it as a good reservoir. We did the structural map at the top of this sandstone, and we ran some seismic attributes, 5, on the surface. So we ran the depth of maximum similarity, instantaneous lateral continuity, shade indicator, relative acoustic impedance, and instantaneous frequency. So this is the first attempt for the seismic attributes works, but we did an integrated analysis of these seismic attributes, and we proposed some polygons where we could have a good development of sandstones related to channel deposits. The second place is a structural ones, play related to an anticline drag fault in the hanging wall of a reverse fault in La Victoria Formation. We have La Jagua field in the Neiba Subbasin. It's the most representative field of this kind. This play most of all have been defined for the Neiba Subbasins, as we can see here in orange. It's the location of this play, the kind of play. It's associated to West Virgin System Trust as a Badaja fault, as we can see here in the seismic line. We have the play here. It's a truck cut of the system, of the Badaja System Trusts. And it's also associated to the thrust propagation fault of the Imbrique system near the Dina, Tejo, Brisas field. Of this play, we identified 2 leads in this sector, in the sector of the Badaja fault, the 2B and 2A, 2A and 2B. And we defined this lead thanks to 2D seismic lines. And the estimate of the potential of prospective resource in late 2A is a P50 of 44.6 million barrels of oil equivalent. And 2B is a P50 of 8.1 million barrels of oil equivalent. For play 3, it's a structural play related to monocline and declining footwall of reverse fault, as we can see in this seismic line. This structure is located most of all in the footwall of regional fault, as we can see here in purple. We have the polygon, purple polygon. In the eastern edge of the basins, but in Hidrocarburos we also have some local faults with associated with this play. So for Neiba Basin, it's associated to the Badaja Garden Algeciras reverse fault, as we can see here in this seismic line, and also in some local area with the Andalusia faults. In the Hidrocarburos Basin, this play is present all along the strike of Prado Suarez system fault. For this play, we also identify 2 leads, 3A and 3B. In the late 3, yes, the 3A is in the same sector as the previous play 2. And for the lead 3B, it's at the west of the Hidrocarburos basins in some local faults, associated to some local faults. Play 4 is an anticline structural play closed in 2 directions by reverse fault and back thrust. As we can see in the seismic line, we have 2 faults with different divergences. This play is also defined just by in the Neiba Basin area. It's in the imbricate system thrust area. And in this north central zone of the Neiba subbasins, it was reported in the well Higueron 1, Yarumo 1, La Colora 1, and Polonia 1, these wells, shows of hydrocarbon in the La Victoria formation, whereby there is an evidence of an effective migration for the in this area for the Onda group. Thanks to 3D seismic, we define lead for A, and the estimate of the potential of prospective resource in this lead is a P50 of 10.8 million barrels of oil equivalent. The play 5, it's a stratigraphic play related to depositation. We can see onlap of the Victoria formation reflectors on Cretaceous formation through an erosive surface corresponding to the middle Miocene unconformity, as we can see in all of these 2D seismic line. The red one is the erosive surface represented middle Miocene unconformity. We can see in here those basins in the central part here in the green area, between Suarez fault and the Cucuana fault to the west, is the sector of the Balcanes well, when we see that this reflector in yellow, the yellow one, has this kind of sandstone. This well just drilled a little bit of this interval, but he has a very good reservoir quality. And in Neiba subbasins, in the northeast sector, we have some local isolated area where we can see also the La Victoria formation onlapping on this erosive surface. So to conclude, we have been able to define 5 plays, 3 structural and 2 stratigraphic. For the 2 stratigraphics, one is associated with a filling of paleochannels, and the other one is associated with onlap on a regional discontinuity. These are the plays with the largest area in the basins, although they are the ones with the highest associated risk related to their delimitation, because the large parts of this sector are only covered by 2D seismic. For the play one, the preliminary work with seismic attributes needs further investigation. We recommend to the future works to have a look of it. And in this work, we study sector where we evidence hydrocarbon show in the Honda group. However, it's recommended in future works to extend this same exercise to other areas with good 3D and 2D seismic coverage. For leads, we only propose leads for structural plays. The synchronism of all leads is positive because the structures that made up the closure are reverse fault that affect the Honda and the Willa group, whereby they have been active for at least 5 million years. And having worked in the sector where La Victoria Formation records hydrocarbons shows would indicate that there is an effective migration path for the proposed leads. However, the risks are associated with the quality of today's seismic and the sealing nature of the fault that close the structure, because of all leads was structural one, were structural leads. But it's also associated with migration related to the amounts that could have filled these structures. And to finish, we want to make a parallelism between land map from the National Agencia of Hydrocarbon and the play we defined in this study. In green, we have the available area with in red the contract number, and in brown we have the polygon where we define plays. So we can see several things. First one, in the exploratory and reserved area where it's white, it is important to mention that in addition to the classic reservoir of Cretaceous, there is also an opportunity in the Cenozoic formation associated with the Honda group, most of all in the northeast part of the neighbor basins. And in available area, we can observe that it exists opportunities in Hidrocarburos Basin associated to stratigraphic play 1 and 5, but also in some isolated sector near to Prado Suarez fault opportunity related to structural plays. This work was focused in the northeast part of the neighbor subbasins because of the well density and because in this part of the basin, we have a lot of shows of hydrocarbon. However, in the south part, we have the Gigantes well and Sarki wells that also show a hydrocarbon manifestation in the Honda group. So this part of the basin is have a very high opportunity for prospectivity in Honda group also. And because of his thickness of the neighbor syncline, I think it would be in the future works very important to investigate this part of the basins. Thank you very much. And I hand over to Cesar Moore for geochemistry.
Thank you, Maria. Good morning, everyone. Now we are going to talk about the petroleum systems modeling, play fairway maps, and the jet to fine assessment. I want to thank all the group. We are in this part of the project. We are involving all the information from the job, and we want to thank everyone, and special thanks to Claudia Posada and Christian Peñafor, my partners in this part of the study. The first point I want to show is a brief summary of the source rock and gas geochemistry. In general, the petroleum geochemistry for the basin. Talking about the source rock, here you can see all the database we have. And according to the pyrolysis data and also with the vitrinite reflectance data, most of the samples correspond to an immature section or early generation, very early generation. That means the geochemical characterization is very close to the original one, to the initial parameters. We can see in at least for Tetuan formation and Loma Gorda formation, Albian and maybe Turonian to Santonian sequence, very high values or hydrogen index, a very high hydrocarbon content, carbon content, organic matter is very, very high. And also we have in so many samples from these units, a huge amount of oil coming during the pyrolysis analysis. We have very high values for the genetic potential. Probably you know, everyone knows that in this basin, we have one of the most important source rock intervals in our country. The amount of oil available for trapping is not related, at the end, it's not related with this quality. Probably we are going to see that will be related most with the maturity level at the size of the productive of source rock. And gas geochemistry here shows that all the gas we have is associated gas, and it is related to primary cracking. That means it is related with the oil window, late oil window. And it is another point, another proof that we don't have a very, very high maturity level in the source rock into the productive of source rock. Kinetics modeling from that kind of phases in Tetuan and Loma Gorda formation shows obviously an oil-prone source rock with an amount of hydrocarbon expelled very close. These values close to 10 million barrels per square kilometers are very close to the values we had, for example, for Middle Magdalena Valley. And that's the same, very, very similar for Tetuan formation. This is Loma Gorda formation, and this is Tetuan formation. The next step was related with basin modeling. We combine 1D, multi-1D, and migration, and 3D for migration pathways. And here we have a summary for the Hidrocarburos basin. This is a model that are including the stratigraphic sequence that was drilled by El Sapo 1, and we are including the last part of the Cretaceous section. As you can see here, for these two source rock intervals, we got something into the gas window, but that gas window is just in the deeper part, obviously, in the deeper part of the productive of source rock. We combining the geological model and the petroleum system modeling, we define this productive of source rock in the northern part. This is the El Sapo area, and here we have the Ilarco area. According to that model, all this oil in place is coming from the eastern part of the basin. We are also including this in our mass balance calculation, the Carmen de Apicala syncline. We believe that we can include that, at least that syncline, because of the geological evolution of this part of the basin. For Tetuan formation, we can see that all this unit is in the gas window today in this productive of source rock. Then as a brief summary, we have Tetuan formation in the gas window today, and Loma Gorda formation sorry about La Luna, is the same age, more or less. We have oil window and a small part, the deepest part in gas window. And this is the model for the southern part of the basin, for the Neiva subbasin. We have a difference for this area when we compare with the Girardot subbasin. The maturity level here is lower than the maturity level for the source rock units. Is lower in Neiva subbasin than the Girardot subbasin. This is the result of the model. You can see that the maximum in vitrinite reflectance will be at the end of the oil window, late generation. Anyway, we have a very good transformation ratio, and this is the distribution of the productives of source rock we can propose according to, again, to the combination between basin modeling and the geological and the structural model coming from the seismic interpretation. We have these two areas for Loma Gorda formation. They are small. You can see that they are small. And we have this biggest one for Tetuan formation in the southern part of the Neiva syncline. The next step was to work with migration pathways. We concentrate the model in the lower part of the Onda group, La Victoria formation. And here we have a model for Girardot subbasin. This is the seismic distribution for that unit in the basin. And you can see here the migration pathways are related with the shape, the general shape of this huge syncline. And also we can see that we have some structural traps that are small. We have a volume calculation coming from the 3D basin modeling software, and they are small. We don't have, excuse me, we don't have traps, a huge traps here, but we have to include for the future the options for the stratigraphic plays. This is just thinking in structural traps that has closure right now according to the seismic interpretation. This is the result. Here we have the result for the migration pathway modeling for Neiva subbasin, and we can see that in the northern part, in the Neiva area, we have a lot of closure, a lot. We have so many. Some of these are higher. The higher closure in the basin are located here for La Victoria formation. Some has volumes, oil in place that are more than 20 million barrels. And also we have for the southern part, the option for stratigraphic plays and structural play. That small green points correspond to these structural closures that we can have in the basin. Combining all this information, the structural maps that are coming from the seismic interpretation, the migration pathways, and the reservoir characterization, we propose this play fairway map, one for Girardot subbasin and this other one for Neiva subbasin. Here we think that we have the option for a play that when we can have structural and stratigraphic traps, combined traps. In the central part, we have the development of structural traps. We have that option there. And in the southern part also, we have some options for structural traps. These plays where we can combine structural and stratigraphic could be really important for the basin, because we know this could be 100 related with the Ilarco productive of source rock. And for Neiva formation, we have all this area where we define this like a structural, the main options for this kind of closure. But anyway, here you can see that in different points of this area, we have a concentration of migration pathways that could be very important for stratigraphic traps. And remember that in this area, we know that the play, the stratigraphic play for La Victoria formation for the lower part of on the group is proof. We have oil, we have oil in place related with this kind of play. And for the southern part, again, we have that option. We have the option for stratigraphic and some structural traps. We can combine this kind of plays in the southern part of the neighbors of veins. The final exercise was to trying to calculate the jet to fine analysis, and we combined the analysis. We did a fractal analysis using the oil in place already discovered in the basin, and we use mass balance calculation. Here we have the results for the first point is related with the fractal analysis. We had 44 fields, almost 3.5 billion barrels of equivalent, oil equivalent in the basin. And the biggest field is San Francisco with more or less 600 million, 0.6 billion barrels. You can see from the current fractal analysis that we have these jumps. That means we have the option to close, to include here new discoveries. The correlation between for this curve is just 90%. That means we have the option to go up, trying to get a better correlation. And that's also, and we can see that's opportunity, or also look at the, if you look at the Pareto law, which is really low, 66 to 34, is so far away for the theoretical relation that 80 to 20. Then using that methodology, we include the fields size we believe we can have. Right now, with that assumptions, we got a correlation very close to 100%. The Pareto will be better, close to 80. And we propose this distribution for new 25 fields. And the final results for using the prognosis from fractal analysis is very close to 2 billion barrels. Remember that the oil in place discovery is 3.6. That means we are thinking that we can add in the basin at least more than 50% that we have discovered. How much could be related with the Cenozoic plays is difficult, especially because quantify the stratigraphic plays is so difficult. But anyway, from this distribution, we know that right now, that place represents more or less 10% of the oil in place discovery. If we use the same relation, that maybe could be the lowest estimation, we can propose that at least 200 million barrels of oil in place could be related in this. With this analysis could be related with the Cenozoic plays. The final exercise in order to compare was mass balance calculations. And here we got a very similar result using the geochemical information and the smoker methodology. We have prospective results around 2.3 billion barrels. In general, we can see something around 2 billion barrels. And that means that we have the opportunity to get new resource in this basin, and probably for the future, that Cenozoic place, especially La Victoria Formation, will be important in order to get this oil that the country is waiting for. Okay, that's all we have. Thank you very much.
Okay, Cesar, thank you very much. So we would like to remind all the people that next week we will have in Ciencias with the presentation about all the opportunities that are for students of last year or postgraduate students. So I'm going to share the screen just a second. It seems that most of the questions that we have in the chat have been already answered by the Professor Javier Guerrero. We would like to remind to all of the attendees that we from the ENH really appreciate if the questions could be asked in English, because we have as well attendees from other countries, and into the recordings that are into the webpage, they are viewed by people from overseas. So we'd like to thank everyone here. So just one second. So don't forget that next week we will have our workshop number 19 with seismic interpretation in the reserve areas, Nueva Granada, acquired by the ENH in 2018. The well drilled by the ENH last year, Pailitas, as well as the details for financial help to postgraduate and last year students. From the ENH, we would like to thank to all of the team from the National University of Colombia. It was an excellent work, and thank you very much. See you next week.